Welcome to the Geography 1 virtual field trip tour. Today I will be bringing you to 4 locations. Our first stop is the mangroves of Fiji, explaining the biosphere. The mangroves of Fiji are trees and shrubs that grow in saline coastal habitats in the tropics and subtropics, mainly between latitudes of 25 degrees north and 25 degrees south. There are 3 types of mangroves: red, black, and gray mangroves. Red mangroves produce leathery brown conical berries that are about 2.5 centimeters long. Black mangroves live on the higher ground structures, which stick out of the soil like straws and small branches. They produce dark green fruits that are about an inch long. Gray mangroves are covered in white salt crystals due to the surrounding of the ocean. They are the most different of the 3 mangroves because of the oval leaf shape. Mangroves are vital habitats that not only protect the coast against tsunamis, hurricanes, and sea level change, but directly benefit the adjacent reefs for exporting life-building carbon. Our next stop is located in the Virunga National Park in Africa. Lithosphere. Nyiragongo is an active volcano that elevates 11,382 feet, about 6 times the height of the World Trade Center. Like many other volcanoes, it has a cone-shaped slope with a 50-degree angle. The rim of the volcano is very dark brown due to the layers of ashes that have been covering it. The type of active volcano it is listed under is a stratovolcano, which is a volcano that was built by many layers of lava, tephra, pumice, and ash. The main crater of the volcano is about 6,561 feet long, wide, and has 2 giant lava benches with a height of 10,417 feet and 9,760 feet. Nyiragongo's lava lake has one of the biggest lava lakes in recent history, which has a depth around 2,000 feet, which is deep enough to drown the Statue of Liberty in it. The volcano is caused by the rift of the Earth's crust, which has 2 African plates breaking apart. Since 1882, it has erupted at least 34 times, setting the record for our largest glaciated area in tropical areas. Heading to our hydrosphere location, Quiquaya ice caps, located in the Andes Mountains in Peru, reaches an altitude of 17,950 feet and spans an area of 17 square miles, which is about the size of a small town. However, due to the rise of global temperatures, Quiquaya lost about 20% of its size since when it was first found. The formation process happens when the temperatures are below freezing or around freezing with snowfall. The tropical glacier today can only exist in high mountain peaks, such as the Andes Mountains, because of the colder layer of the atmosphere. When the ocean water in the equatorial oceans are ice-free, they have enough moisture to evaporate and then form snowballs over the mountains, which causes the growing of glaciers high up in the mountains. For our last stop, we will make our way to South New Zealand to the auroral zone, which is located typically 10 degrees to 20 degrees from the magnetic pole. Here we will find the best view to watch the aurora australis. At the highest and lowest altitudes on the planet, sun, atmosphere, and magnetism collide to paint the sky in curtains of bright neon lights. Down south, it is the aurora australis, or southern lights. Auroras themselves are not rare, about 60 to 200 miles above Earth. Collisions are lighting up in the bright colors of neon green, occasionally red or pink, and more rarely blue-purple emissions. Seeing them from the ground, though, requires certain conditions such as darkness, clear skies, and particularly active sun, and finding oneself in one of the auroral zones. The 2 auroral zones on Earth appear as ovals over the north and south magnetic poles, respectively. Sightings outside these ovals are practically unheard of, and even within the aren't guaranteed. And that wraps up our virtual field trip tour. Thanks for coming along and have a great day.